This is for Year 12 Specials. It comes out of the chapter review of Chapter 3 when we're trying to use compound angle rules, Pythagorean identities or double angle formulas to try and solve equations, and we have a restricted domain from negative pi through to pi. So I can see a double angle formula here. So I would like to use this to try and solve it. So 2 sine of x cos of x equals the sine of x. I move the sine of x over. 2 sine of x cos of x minus the sine of x equals 0. Now I've got a common factor of the sine of x. So the sine of x outside of 2 cos of x minus 1 equals 0, which says the sine of x equals 0. And that will occur x equals minus pi, 0, pi, and 2 pi. Or 2 times the cos of x minus 1 equals 0, which means the cos of x equals a half. And that's going to happen in the first, and that's going to be cos of x equaling a half will be pi on 3, minus pi on 3, and 5 pi on 3. So all of my answers for x are x equals minus pi on 3, 0, pi on 3, pi, 5 pi on 3, and 2 pi are all of the answers that make that equal to that. In this one here, because I've got the cos of x but the cos of 2x, I'm going to use one of the cos of x's. However, since I've already got a cos of x, I'm going to choose this version of the cos of x. So I'd be saying that the cos of x minus 1 equals 2 cos squared of x minus 1. Move all of that over. 0 equals 2 cos squared of x minus the cos of x minus 1 plus 1 is 0. Then 0 equals cos of x outside of 2 cos of x minus 1, and therefore I can solve them separately. If I move down here and I have a look at this question here, because I've got the cos of x squared and the cos of x plus 1, I think that this looks like a quadratic. So I'm going to say let a equal the cos of x. We've got 2a squared minus 3a plus 1 equals 0. I can crisscross that, I think. 2a and a, 1 and 1, with them both being negative. That's correct. So I've got answers which are 2 cos of x minus 1 and cos of x minus 1 equals 0. Therefore, the cos of x equals a half and the cos of x equals 1. Solve them each separately. In this one here, I've got the sine squared and the cos cubed equals the cos. So I better bring the cos over. So I've got sine squared of x cos of cubed of x equals, minus the cos of x equals 0. If I take a cos of x out, that will give me sine squared x cos squared x minus 1 equals 0. I can use this identity around the other way. So I could then say that this is the cos of x times 1 minus the cos squared of x times the cos squared of x minus 1 equals 0. And inside here I'm going to have cos squared of x minus the cos to the 4th of x minus 1 equals 0. I could put the negative all the way out the front. Cos the 4th of x minus the cos of x plus 1 equals 0. And I could treat that like a quadratic formula. Let a equal the cos of x, a to the power of squared, no, not squared, because that is squared. So a squared minus a plus 1, maybe use the quadratic formula to solve that. So what I'm doing is I'm rearranging using these here, depending upon what aspect we see, to be able to factorise or to turn them all into the one sine or cos to then be able to solve.